Hello students, welcome to another session of this three-dimensional geometry, and today we will be dealing with one of the simple concepts, that is finding the coordinates of foot of perpendicular drawn from the origin to the plane. Means this is your normal and we are interested in coordinates of this point. Okay, so let us study with the help of an example. Okay, so you will be given one general equation, that is ax plus by plus cz equal to something constant. Okay, remember that this is not in the normal form. These are not L and N. These are direction ratios of the normal. So you will be given like this. So you need to find coordinates of this point. So let us try to understand with the help of an example. Okay, so we need coordinates of this point. So let's see the first example. Find the coordinates of the foot of the perpendicular drawn from the plane to the origin. So you are drawn a perpendicular from the plane to the origin and you need coordinates of this point. Okay, so let us assume that the coordinates of this point are x1, y1, z1. Okay, so let M be the foot of perpendicular from the origin to this plane. So this is your given plane. Okay, so your given plane is this. You can write this plane is, so your given plane is, you can write this is your given plane, 2x minus 3y plus 4z minus 6 or equal to 6 can write. Okay, so this is your given plane, and now you need to find the coordinates of M. First you need to find what are direction ratios of OM and direction cosines of OM. Okay, so conceptually you will understand. So what are the direction ratios of OM? We know that direction ratios of line joining two points, x2 minus x1, y2 minus y1, and z2 minus z1. Okay, so find the direction ratios of OM, that is x1 minus 0, y1 minus 0, z1 minus 0. That gives you x1, y1, z1. So they are denoted by A, B, C. Now we will move to find direction cosine. Okay, so given plane is this, transfer 6 this side, divide throughout by square root of 2 square plus 3 square plus 4 square, that is root 29. Okay, because these are the direction ratios. If you divide, you will get direction cosine. Okay, so on dividing, you will get 2 by root 29, 3 by root 29, and 4 by root 29, 6 by root 29. Now if you square and add them, okay, so definitely you will get 1, that is L square plus M square plus M square. Okay, now this stands for L and N. So this is your L, this is your M, this is your N, and now this is in the standard form. I will write it as, it will be in the form, or it is in the form, this is in the form, okay, this is in the form Lx plus My plus Mz equal to D. So this is in the normal form. Clearly, if you square and add them, you will get definitely 1. Okay, so what are the direction cosines now? The direction cosines are 2 minus 3 by this 2 by root 29 minus 3 by root 29 and 4 by root 29. Okay, so these are your L and N. Okay, so this is your L, this is your L, and this is your M, this is your N, and this is your D. Okay, so this is your D. So what we'll get, so D is 6 by root 29. Now we know that relation between direction cosines and direction ratios. So direction cosines and direction ratios are proportional. So A by L, B by M, C by N equal to K. So A is equal to LK, or B is equal to MK, C is equal to NK. Okay. So substituting A, B, C, what we found: A as X1, B as Y1, and C as Z1. So X1, Y1, Z1, and L already known to us, M is known to us, N is known to us. Okay, L was 2 by root 29, M was minus 3 by root 29, and N was this. So these are the X1, Y1, Z1. And see that X1, Y1, Z1 is a point on the plane. Okay, so first we will learn conceptually. So X1, Y1, Z1 is a point on the plane. So this point satisfies equation of the plane. Okay, so that is why you substitute x1, y1, z1 in this equation. So substitute these in equation 1. This is your equation 1 or this. So substituting x1, y1, z1 in place of x, y, z, so you will come up with this equation. Okay, now substitute in terms of k. X1 is this, y1 is this, z1 is this. Okay, so 2 into 2, 4, it's plus 9 plus 16, and root 29, transfer this side, you will get 6 root 29. Okay, adding these, you will get 29k is equal to 6 into root 29, and k is equal to 6 by root 29 by 29. And if you rationalize this, okay, or you know this, you can use this. You can use root x by x is 1 by root x. Okay, so root 9 by 29 means 1 root 29 remains here. So using that we can, so in this way you can find the value of k. And after finding the value of k, you substitute in the value of x1, y1, z1. Okay, so this is your x1, 2k by root 29. K is known to us. Substitute here, 2 6 plus 12 by root 29. So similarly y1 is this, and z1 is this. Okay, so this is the theoretical way of finding. Now actually direct way is, see here what we have done here, the value of k was equal to d. So your d was 6 by root 29, and even k is also the same thing. Okay, so if you do theoretically, the value of k is equal to the value of d. So, and these are what, 2 by root 29, this is your L. So minus 3 by root 29 is M. So actually the coordinates can be found directly by this. This is the product of L into D, and this is the product of M into D. So this is the product of M into D. So directly just you find the direction cosine of the normal and the distance of the, or the length of the normal. So once you find those quantities, just find the product of those, that gives the coordinate. This is the direct way of approaching. Okay, so let us understand another example in direct way. Okay, so these are the coordinates of put of perpendicular. Okay, so let us try to example. We try to solve one more example. So what I explained is here. So if the given plane is expressed in this form, Lx plus My plus Mz equal to D, then you can find it, the foot of perpendicular, coordinates of foot of perpendicular of the normal in this way, LD, MD and D. Okay, so here is the example. Find the coordinates of the foot of perpendicular drawn from the plane to the origin. Okay, this is the equation. First you need to express it in the standard form, that is Lx plus My plus Mz equal to D. Okay, so this is actually 2, 3, 4 stands for, they are the direction ratios. Now you need to find direction cosine. So that is why you need to divide through it by 2 square root of 2 square plus 3 square plus 4 square, that is root 29. So after dividing, you will get this 2 by root 29, 3 by root 29, and 4 by root 29 equals 12 by root 29. Clearly, this is in the form of Lx plus My plus Nz equal to D. So LMNR, what are direction cosine? So L means this, M means this, N means this. Okay, and this stands for length of the normal, that is D. Okay. Now, what I said earlier, product of the direction cosines and D gives you coordinates of the foot of perpendicular of the normal. So LD into LD, MD, ND. So LD means product of L into D. 2 into 12, 24, root 29 into root 29, that gives you 29. Similarly, 12 into 3, 36 by root 29 into root 29, 29. Similarly, 4 12 are 48, root 29 to root 29 is 29. In this way, you can directly find coordinates of foot of perpendicular. Okay. So remember one thing, just divide towards by sum of the squares of the coefficients of x, y, z. So you will get LMN and D simultaneously. Then find it. So let's have one more example. So here is the example. Find the coordinates of the foot of perpendicular drawn from the plane to the origin. To the plane. Okay. So first you divide it by this your given plane. Divide throughout by 1 square plus 1 square plus 1 square under root, that gives you root 3. So on dividing you will get 1 by root 3, 1 by root 3, 1 by root 3, x, y, z equal to 1 by root 3. So clearly this is in the form of Lx plus My plus Nz equal to D. So LMNR 1 by root 3, 1 by root 3, and D is also 1 by root 3. Okay. Now you can write the coordinates LD, MD, and D. So 1 by root 3 into 1 by root 3 gives you 1 by 3. Similarly, 1 by root 3 into 1 by root 3 gives you 1 by 3. And this is also 1 by 3. So in this way you can find coordinates of foot of perpendicular. So there is one more example for your understanding. Please try it. Okay. So here x is not there means you can try to take it as a 0x. So answers are this. Let me show you. Okay. So given can be written as 3y plus 4z equal to 6. You may write 0x, x is not there means, and divide by square root of 3 square plus 4 square, that is root 25 you will get, and that is your 5. So on dividing by this quantity, you will get 0 by 5 x, 3 by 5y, 4 by 5z equal to 6 by 5. Clearly, LMNR says L is 0 by 5 means 0. This is your L, this is your M, this is your N. And 6 by 5 is your D. Multiply these, you will get. So very simple concept and understand. So in the next class, we will be coming with one more equation of plane. So till then, take care and bye. Keep studying.